Hey friends, welcome back to the channel, and in this video let's discuss about where are the different places in which we can cache it, or we can say that we need to discuss about multi-layer caching strategy. But before that, we need to understand that more cache layers can lead to complex invalidation and more staleness of the data, and it is not required to cache everywhere. We just need one or two places where it is going to be a strategic decisions where the things are going to ease out a lot. And some data cannot be cached, for example, financial transactions or bank balances, etc. So need not to cache it there. So let's talk about different caching layers. So these are just the overview. We'll be talking about in detail about all of these. First is client-side caching, which are browsers, applications, etc. Now these are the fastest because there is no network call in that. Second is the CDN cache. So these are for the geographically distributed data, for example, Cloudflare, etc. And these are very fast because we need not to carry from the original server, but from the geographically nearest server. Third is the remote cache. So this is, I think, mostly talked about, like Redis, Memcached, etc. These are centralized and network accessible. And fourth is database as a cache, or we can have some kind of pre-computed results that we can have. So let's talk about each of them one by one. So first, let's about client-side caching. So this is pretty common, and you might have seen it in the Amazon Prime Video or Netflix. So what happens is, if you open that app, you'll see that recently watched videos or recently watched movie shows, TV series. So all of these things are like device specific. So if you have watched any movie in your phone, you can have that data is cached in your mobile application. And if you open your same account in the browser, you will not see that continue watching thing. So this is a very good example of client-side caching, meaning that in the browser or your mobile application, that data is cached. So there's no network layer. It is very fast, no network latency, and it reduces server load massively. And not just that continue watching tab, that is just an example. We can have a ton of data like images, CSS files. We can have separate JavaScript bundles and recent activity and everything. But coming about the drawbacks, we can have consistency across different devices. As I talked, we'll have different cache for different devices that we are browsing on Prime Video. For example, we don't have any central control over invalidation, and there is limited storage space. So talking about mobile devices, there is limited storage space, hence the limitation to the cache as well. Second, let's talk about CDN. So we have talked about CDN in our previous video in detail as well. Just to give a quick recap of that, what happened is we have different servers spread across different geographical locations. So let's say we have original server in Sydney, and we need to have we are querying some static data to our machines here in India. So querying everything to our Sydney server is going to be very difficult. So if there is any CDN located in India, we are going to have that request directly served from our Indian server. If we don't have any specific thing in that particular server, we are then going to query our original server. So this is on the higher level what CDN is. If you are more interested in going deep dive in the CDN specifically, you can watch my previous video. So this is a simple example that you can refer. Third is the remote cache. So common example for that is going to be Redis or Memcached. This is centralized and in-memory cache that is accessible all over the network by all the API servers. some key characteristics include they are centralized, these are network accessible, it is in memory RAM based, so it is very, very fast. Common example, Redis and Memcached, obviously. Now, what to cache? So these are mostly located before the databases. So as we had discussed in our previous videos as well, so we are going to have some kind of caching policy with us. For example, least recently used or least frequently used. We can have number of database query with us that we are going to cache. We can have many session data with us, or API responses, or like frequently accessed data that we can cache. Now, talking about cache, we need to have our TTL or expiry date so that we can avoid memory leaks or redundant data with us. TTL is time to life, and the cache size is going to be very, very low as compared to the data size. So we need to be selective about what to cache, and we need to like pop out all the redundant data as we have limited space. Now, in the end, let's talk about database as a cache. So this is just a simple trick that you can have. So let's say you are building a system, let's say medium.com, and you have multiple blog posts, and you are using some kind of relational database. You have rows and columns, you have a specific user ID in which you have the post for that user ID, all the posts that it has developed. So for example, you want to query a specific thing. What are the total number of posts that user have? Now, if you don't have that thing pre-computed with you, you need to go through your disk, your database overall. You have to check all the blog posts published by that particular user. So this is very time consuming. Now, on the other hand, what you can do is you can have a simple counter associated with each user ID. And whenever there's a blog is published on that particular user ID, you will add the row for that user ID and the blog post, etc. Also, what you're going to do is update that total post value. So in this case, so here is a good example of the transaction that is done. And in this case, there is no expensive count query every time that you need to have the total number of post by that particular user. You can have a single select statement, and the database transaction keeps the data consistent. So this is a kind of pre-computation to avoid expensive computation every time on the database. So this is a kind of a tricky way to use your database as a cache. Now, this is the cache layer comparison. We can compare all the 4 type of cache that we had discussed, that you can have a look, and the decision framework of where should I use cache. So there are a few things that you need to understand about the requirements of your system and what are the specific things that all of these different type of caches are delivering. So for example, we can have what type of data that we need to cache. Are those static images? We can use a CDN or a client-side caching. Are these dynamic but geographical distributed users? We are using CDN. Is that hot data or some kind of frequently accessed data? We are using remote cache. Do we need expensive aggregations? Then we can simply have a database cache in place. Now, how fresh does data we need to be? Do we need it real time? We won't cache. Can we tolerate 5-10 minutes staleness? We can have a remote cache with us like this. Where are the users located? Are those global users? We are going to use CDN. If not, we can have a look at other type of caches. What's the access pattern like? Is it read heavy or it is write heavy? And how critical is the consistency to us? If it is quite critical, we don't cache, or we can have some kind of database cache because it is transactional. If it is not critical, we can use any cache layer with us. So these are the different kind of questions that we need to ask and we need to have the priority with us, and keeping all of these things in mind, and the different features of all the database of all the cache layers with us, we can make a educated guess, or a pretty good we can have pretty good trade-offs between all of these, and we can come up with a specific caching strategy. Now, one thing to keep in mind, we need not to over cache our system, because when we have because what happens is, when we are caching at every layer, we have a pretty bad architecture. So for example, we have a client cache, then we have a CDN, then we have a load balancer cache as well, remote cache, database cache. So all of these, what happen is, we need to update database, and we need to invalidate our database cache, remote cache, load balancer, CDNs, client cache, everything. So because of this, we'll have massive staleness and very complex invalidation. We are updating this particular thing, and we have to kind of invalidate everything before this. So we need not to over cache our system design. We need to have one or two strategic layers, keeping the trade-offs and the system requirements in mind. We need to have one or two strategic layers, and that will be everything, and that will be pretty good for most of the system design. So this was the whole discussion about the different kind of cache layers that we can have, when to use, and what is the best strategy to take. We need not to over cache our system, but we need to have a pretty good understanding of the trade-offs, requirements, and then we can have a couple of caching layers in our system. So that's about today's video. Hope you like the discussion. See you in the next one.